Okay, so we're continuing on in chapter 8. This one is 8.2. A single population mean. A single population mean using student t distribution. Student t distribution. So essentially, what's happening here is we are talking about when our sample size is small. When our sample size is small, the z-score does not give us accurate results. So actually somebody from the Guinness Brewery, I think William Gossett is his name, discovered this as he was doing experiments with his hops and barley. His sample sizes were just too small. So he noticed that replacing sigma with S did not produce accurate results. So when he was doing his confidence intervals. So he found that he discovered through those processes that if you use the student's t distribution, and it's called students because that was his pen name he used while he was experimenting. He wrote under that pen name. Distribution. The student's t distribution will give a more accurate confidence interval when our sample size, we're going to have to specify what small means. So we're going to say when our sample size is less than 30. So the way we find the t-score is going to be the equivalent of a z-score, except we have a small distribution. The t-score will be x bar minus mu divided by s over the square root of n. All right, so we have what, in addition to needing these pieces of information, we have what's called degrees of freedom. When we use our calculator, we're going to have to specify what our degrees of freedom is. And the degree of freedom is basically n minus 1. Whatever our sample size is minus 1. And that's going to calculate more accurately. All right, so let's go ahead and do an example. I'm going to go straight to the calculator method as opposed to showing you the analytical method where you would do it by hand, where you would take the x bar plus or minus the EBM. So instead of that, we're going to use the calculator method. All right, so let's just say we have, let's switch to blue for our example. Let's say we have a mean, a sample mean is 127.45. I had a chart that I was going to show you and we were going to calculate the mean, but I'm just going to go ahead and give it to you. And the S is 25.965. So this, more specifically, this was understanding pollution in the human body. So this was industrial chemicals, the percentage that were in the body. All right, well, let's keep going here. So it's on the slideshow. You can go and look at what this comes from. It is, I'm trying to figure out what slide that is. Slide 30 is where our data is coming from. So there are 20 infants in the sample. So n is going to be 20. That means our degree of freedom, the DF, is going to be that n, that 20 minus 1. So that'll be 19. So we're asked to calculate a 90% confidence interval. All right, so that means our confidence level is 0.9. So that means that alpha will be 1 minus 0.9, so it'll be 0.1. Again, that alpha over 2 will be the 0.05. All right, so, but we want to find, again, I'm going to go straight to the calculator method for finding the confidence interval, a 90% confidence interval. So let me switch colors. I will go to, let's this color right here. All right, so calculator method for the t-distribution. All right, so I want you to go over to stat. Hope you have your calculator out. Go to stat and arrow down to tests. Stat, then tests. We've been here before. Stat, tests. Then we're going to go down to number 8. If you go down is t-interval. You may have to use the down arrow. So number 8 is going to be t-interval. We used z-interval last in section 8.1. So it's right underneath that, t-interval. Press enter. And then you're going to see an option for, you're going to fill in your mean. You're going to fill in that standard deviation, it says S of X and mine, your N, the C level, that's your confidence level, and then you're going to hit calculate. So in this example, from up above, we said our X bar is 127.45, 127.45. Our standard deviation is that 25.965. Our N is 20. And our confidence level is that 90%. So we're going to say is 0.9. We're going to hit calculate once we enter all of that. And we should come up with an interval. Mine is 117.41 and 137.49. So we can say that we are 90% confident that our mean falls in this interval right here based on our sample. Even though we had a small sample size, we are 90% confident that our mean, our true mean, falls in this interval right here.